We're never going to stop exploring the unknown in air and space.
Voyager, in some very real sense, is material that's not from the medium in which it finds itself.
NASA's Voyager 1 is a quiet spacecraft that is now traveling over enormous expanses of space. It has been traveling across space for an amazing 45 years, all the while providing us vital information from remote parts of our solar system. However, something quite odd is happening right now. Now an astounding 24 billion kilometers beyond Earth, Voyager 1 has begun returning startling data that has scientists scratching their heads in disbelief. Is Voyager 1 coming across anything really different on its intergalactic voyage? Come along as we solve the enigma behind the peculiar signals Voyager 1 has been transmitting, which have baffled experts. The Voyager mission was only supposed to last 5 years when it set out on its voyage in the summer of 1977. But Voyager 1 and Voyager 2 shocked everyone by doing better than anticipated. Rather than closing down, they persisted in their mission for more than 45 years, reliably returning vital scientific data from the periphery of our solar system. These two spacecraft were initially sent to investigate Jupiter and Saturn, a task they successfully completed. Voyager 1 didn't end there, though. It set off on an incredible voyage, being the first spacecraft to closely observe Neptune in 1989 and Uranus in 1986. The Voyager Grand Tour was the name given to this period of exploration. The Voyager 1 spacecraft achieved something remarkable in August 2012. It moved into interstellar space, a region of space outside of our solar system. This incredible achievement was accomplished barely 35 years after Voyager 1 set off on its mission from Earth. However, when it continued its investigation beyond the solar system, the spaceship had even more amazing feats in store. However, scientists didn't make any noteworthy discoveries until 2013. They went over all of the data that Voyager 1 had returned with great care. Then, NASA officially declared that Voyager 1 had left the solar control region and entered interstellar space, going farther than anybody had ever dreamed. It encountered a steady stream of particles and magnetic fields there, which was completely unfamiliar to the spacecraft. Now, at an astounding distance of 24 billion kilometers, Voyager 1 is the farthest object ever built by mankind from Earth. NASA's Jet Propulsion Laboratory monitors these amazing expeditions. Voyager 1 is traveling through space at an astounding speed of nearly 38,000 miles per hour or 17 kilometers per second as it passes us by. Because the Voyager missions have provided us with unique knowledge about our solar system and its surroundings, they have been extraordinarily special. The interstellar medium, the region between stars, and the solar wind, the steady stream of charged particles from the sun, have been the subject of intense investigation by these probes. The heliosphere, a charged particle bubble that surrounds our solar system, is another concept that has been clarified by Voyager data. The area surrounding this bubble shapes it. All things considered, the Voyager missions have greatly increased our understanding of and enthusiasm for space exploration. They will live on in our memories for a very long time since they had a significant impact on space exploration. Meanwhile, scientists predict that in 2029, we may have our first encounter with extraterrestrial life. They believe that if there are aliens in the universe, Voyager may first have carried our communications back to them in 2002. There is a great deal of interest in the potential outcomes should Voyager 1 come into extraterrestrial life. This hypothetical situation piques our interest and asks us to consider the possible consequences of such a remarkable occurrence. The hardest environment imaginable is being traversed by the unbreakable space pioneer Voyager 1. Extreme radiation, bitter cold, searing heat, and even small pebbles hurtling across space are all there. Most things couldn't endure in those environments. However, Voyager 1? It has continued for an amazing 46 years and 5 days. That would be akin to a super powerful superhero surviving several obstacles in space and continuing to be strong. This spacecraft's exceptional strength is largely responsible for its lengthy lifespan. Its designers and engineers were astute enough to ensure that it would be resilient to a wide range of harsh environments, including space rocks and intense heat and cold. Its unique power source, a nuclear battery, sometimes referred to as a radioisotope thermoelectric generator, is another reason it is still operating today. Even in the furthest reaches of space, these batteries keep everything operating flawlessly. This spacecraft is fully furnished with a variety of equipment, including ones for monitoring temperatures, researching cosmic rays, and taking excellent photos. These instruments have accomplished some amazing feats and are not only showpieces. They have been employed by Voyager 1 to learn more about large planets and their moons. However, Voyager 1's instruments aren't limited to taking amazing photos. Comparable to cosmic investigators, they research charged particles, magnetic fields, plasma waves, and cosmic rays. A unique message from Earth was also delivered by Voyager 1 on its journey across space, intended for any unidentified species it might come across. The so-called Golden Record is a message demonstrating humankind's attempt to communicate with potential aliens. Voyager 1 and seizing cosmic wonders. Voyager 1 set off on a remarkable interstellar mission with a remarkable message from Earth for any unidentified beings it might come across. The Golden Record is a special message that symbolizes humanity's attempt to speak with possible alien life forms. The Golden Record itself is a unique artifact. It is a copper disc with a gold coating that has a diameter of around 12 inches. It features audio and visuals that have been carefully chosen to highlight the variety of life and civilizations on Earth. Beyond its outward appearance, the Golden Record is a doorway into the earthly realm. As a symbolic effort to establish communication with potential extraterrestrial civilizations, it tells the tale of mankind and our planet. Consequently, Voyager 1 serves as a messenger, transporting the essence of human life to the farthest reaches of space, in addition to carrying scientific equipment as it continues its cosmic voyage. In the far future, aliens may find the message this spaceship is bringing from Earth. Should a highly developed extraterrestrial society by accident come across Voyager 1 and retrieve the Golden Record it holds, it would be a momentous occasion in the annals of interstellar communication. 3 fascinating hypotheses surround the unknown fate of the Golden Record of Voyager 1. First of all, if extraterrestrials find it, they may use their sophisticated technology to interpret the sounds and visuals it contains. Second, scientists estimate that a response might reach Earth by 2029 if these aliens are able to travel over the great distances between stars or speak with one another. This could possibly establish a new channel of interstellar communication. Nevertheless, a third scenario is that these mysterious entities choose to see Voyager 1 as a relic of the past and avoid communication in order to let emerging civilizations develop unhindered. And contact of this kind between us and extraterrestrial intelligence would have far-reaching ramifications, potentially altering the very structure of our planet. Scientists' interest about the immense unknown beyond our solar system is piqued by Voyager 1's latest broadcasts from the furthest reaches of interstellar space. Voyager 1's own voyage became mysterious as it traveled across space, bearing the fascinating Golden Record, a monument to human curiosity and longing for contact with possible alien life. Unexpected broadcasts from the remote regions of interstellar space have captured the attention of astronomers recently. These puzzling indications from Voyager 1's onboard systems have confounded NASA engineers and given the project an exciting new facet. While Voyager 1 continues to explore the universe and communicate our presence to the unknown, it has also become a source of mystery, which has led academics to redouble their efforts to comprehend. However, this celestial explorer was far from finished with its task. Unusual signals sent to Earth by Voyager 1 despite providing consistent and long-lasting service, signals from the furthest regions of interstellar space have recently piqued scientists' interest. NASA engineers are baffled by this unexpected data, especially because it originates from an important onboard device known as the Attitude Articulation and Control System. The mission of Voyager 1 is further complicated by this anomaly, which raises questions about its importance and potential ramifications for researchers. The spacecraft's continued functionality and the perplexing data it sends highlight the difficulties involved in space travel and the continuous quest to solve the universe's secrets. There is a problem with the system that determines the spacecraft's location and fixes its position so it can communicate with Earth and relay data, the attitude and articulation control system. There are instances where the attitude and articulation control system provides inaccurate data. It gives the impression that the spaceship is traveling differently than it actually is. It's as if the spacecraft Voyager 1 is disoriented and has forgotten its location in space. It's floating around in the vast nothingness of space, which makes it odd. It raises questions about our ability to trust the technologies that assist the spaceship in determining its direction. NASA claims that its grasp of the situation is both reassuring and puzzling. Voyager 1 continues to function correctly even when its control system provides incorrect information. It collects crucial information from a distance and pays attention to commands from Earth. The issue doesn't seem to concern the spaceship, and its safety mechanisms haven't activated. In the event of a malfunction, these mechanisms are meant to safeguard the ship. The reason it's interesting is that it demonstrates that Voyager 1 is still functioning well despite certain issues that are still unclear. It's interesting to note that, like a guiding beacon, Voyager 1's signal endures throughout space. Its large antenna remains fixed toward Earth. However, there's an oddity with the information it receives back from the system that aids in directing it. At times, the data it transmits appears disorganized and nonsensical. This raises questions among scientists regarding Voyager 1's communication system. The head of both the Voyager 1 and Voyager 2 missions, Suzanne Dodd, clarifies the perplexing circumstances. She reminds us that mysteries are nothing out of the ordinary at this point in the Voyager mission. More time and distance have been traveled by this spacecraft than was initially anticipated. They are currently venturing toward the region where no spacecraft has ventured before, the gap between stars and intense radiation. The engineering crew is optimistic that they can resolve Voyager 1's guidance system issue despite the difficult task ahead of them. They may be able to resolve the problem by utilizing backup hardware or altering the spacecraft's computer programming if they can identify what's causing it. In order to keep the mission going, NASA's highly qualified engineers have identified a problem with the Attitude and Articulation Control System, AACS, on board the spacecraft. It seems that the AACS was sending telemetry data to a computer that was broken and had been for a long time, which caused data corruption. With suspicions that this was the main reason, the project manager made a bold decision to keep telling the AACS to send data to the right computer. The engineers are still unsure of the reason behind the AACS's deviation from its planned path. They hypothesize that this anomaly may have been caused by a directive from another onboard computer that went wrong. If confirmed, it suggests that there is a fundamental issue with the spacecraft. This discovery emphasizes the difficulty of space travel and the creativity and calculated risks that NASA's crew took to overcome unanticipated challenges and continue the mission. We stay in contact with Voyager 1 thanks to a well-thought-out radio communication system. This technology has been painstakingly designed to function well both inside and outside of our solar system. A large 3-meter diameter high-gain crane antenna sits at the center of it all. Radio waves cannot be broadcast or received without this strong antenna. It collaborates with the 3 ground-based stations that make up the Deep Space Network. The main challenge in communicating with objects at great distances, such as those in outer space, is ensuring that our technology can detect extremely faint signals. However, Voyager 1 was equipped with some of the most cutting-edge communication systems available at the moment. Voyager 1's innovative communication network. Radio frequencies of either 2.3 GHz or 8.4 GHz are used by Voyager 1 to interact with Earth using Deep Space Network Channel 18. On the other hand, we utilize 2.1 GHz to send messages to Voyager. Voyager 1 is able to stay in contact with Earth because to this advanced configuration, even as it travels across the great unknown of space. Voyager 1's communication system is like a lifeline reaching out from our planet into deep space. The spaceship needs this system, painstakingly designed by scientists and engineers, in order to communicate information back to Earth and receive directions for continuous functioning. The massive 7-meter diameter high-gain crane antenna is the focal point of this communication system. Voyager 1 uses this antenna as its main radio transmission and receiving device. Even when it travels well beyond the boundaries of our solar system, it may pick up sporadic signals from the spaceship with meticulous calibration and alignment. The Deep Space Network is used to enable this communication. This network, which consists of 3 carefully placed earthly stations, is an essential conduit between Voyager 1 and mission control. These stations put up endless effort to monitor the spacecraft's motions in order to maintain a steady stream of data between Earth and Voyager 1. To maximize transmission efficiency, the frequencies utilized for communication are carefully selected. Depending on the mission's objectives, Voyager 1 uses frequencies of either 2.3 GHz or 8.4 GHz to communicate with Earth. The frequency at which signals are sent from Earth to Voyager 1 is 2.1 GHz, in contrast. Reliability of communication even across long distances is ensured by this careful coordination. Despite the difficulties brought on by space travel, Voyager 1's communication system is an example of human resourcefulness and tenacity. As it continues its historic voyage into the uncharted territories of space, it enables us to maintain contact with this groundbreaking spacecraft. The distance Voyager 1 has gone makes it harder and harder for it to stay in direct contact with Earth as it continues its voyage into space. The spaceship has a digital tape recorder that can store about 67 megabytes of data in order to meet this objective. With the help of this recorder, Voyager 1 can store important data on board that can be sent back to Earth when communication conditions are more favorable. By 2023, signals from Voyager 1 will have traveled over 22 hours to reach Earth, a considerable increase over the 15 minutes it takes for data from the Mars rovers to reach us. This enormous disparity emphasizes how far Voyager 1 has traveled beyond Earth. And further barrier to contact is that Voyager 1's signal gets weaker as it moves across space. The Deep Space Network, DSN, which NASA employs, consists of 3 antenna sets that are positioned strategically throughout Earth. A large 70-meter antenna and several smaller 34-meter antennae are included in each group. Together, these antennas are able to pick up signals that are often thousands of times weaker than typical FM radio frequencies. The DSN facilitates communication between us and spacecraft traveling to far-off regions of space. The connection between Earth and these spacecraft is similar to a dedicated phone line. Thanks to this method, data may be sent and received from spacecraft to scientists and engineers, even when they are very, very far away. It's an essential instrument for space exploration and education. The system allots a significant amount of time each day to scan for Voyager 1's feeble signals. In the past 50 years, it has consistently responded quickly. This amazing ability depends on the availability of accurate, sensitive receivers that can consistently pick up very low signals. These signals are so feeble that sophisticated equipment is needed to identify and analyze them, even yet they contain important information from far-off celestial entities. By using these instruments, we may create a dependable channel of communication with distant objects in space, which broadens our knowledge of the cosmos and distant planets. This finding makes it possible for humans to connect with items that were previously out of reach and span enormous cosmic distances, which creates new avenues for study and discovery. These developments in space communication technology mark an important turning point in our efforts to explore the limits of human knowledge and solve the mysteries of the universe. Due to its energy limitations, Voyager 1 is unable to collect as much scientific data as it would like. The cosmic ray subsystem, one of its primary instruments, is devoted to the analysis of particles released by celestial bodies like stars. This device is essential to providing us with insightful information about the cosmos. We are able to learn a great deal about the makeup and behavior of far-off cosmic occurrences by studying these particles. Despite the limitations imposed by its limited energy source, Voyager 1 is determined to solve the cosmic mystery and advance our knowledge of the vast and complex universe. Scientists are able to get a deeper understanding of the intricacies of the cosmos by investigating the origins, compositions, and behaviors of celestial objects through the data gathered by equipment such as the cosmic ray subsystem. What is actually out there, though, is much beyond space. Discoveries beyond the pale blue dot in 1990, scientists had to make a critical choice. In order to conserve electricity, they turned off the camera aboard Voyager 1. Only 5 of the amazing instruments Voyager 1 carried with it still function, and this was shortly after they captured the now famous image of Earth known as the pale blue dot. Switching off the camera was a wise decision. It enabled Voyager 1 to continue traveling through space and relay crucial data back to Earth. The other functional features provide us with additional information about space even when the camera is off. The image of Earth, the pale blue dot, serves as a constant reminder of how little our planet is in relation to the vastness of space. Voyager 1 demonstrates how much we want to learn about space by continuing even with fewer instruments. NASA has begun to reduce its energy use in order to extend the life of Voyager 1 into 2025. Rather of shutting down one of the tools sooner, they are postponing it until 2026. However, by 2025 or 2026, several tools might no longer function. The mission is anticipated to conclude in the mid-2030s. This demonstrates NASA's sincere desire to get as much data from Voyager 1 as possible before it ends. Voyager 1 forces us to consider how people explore and learn about space as it draws to a close. The engineers had to make difficult choices in order to keep these equipment operating. In order to keep these active instruments working, they had to turn off heaters and other parts. These tools are still essential for gathering valuable data about our surrounds in space, even with these modifications. As their eyes and ears, they enable us to see into the depths of space. They shed light on magnetic fields, solar winds, and extrasolar cosmic rays by collecting crucial data. The information contained in this statistics is crucial for comprehending space dynamics and how it affects our surroundings. These devices are vital to expanding our understanding of the cosmos, despite the costs incurred to maintain them. NASA began using energy-saving measures in 2022 in order to continue its mission into 2025. However, as of 2023, they claim to be taking even more energy-saving measures, which include postponing the shutdown of one of their scientific instruments until 2026 rather than sooner. By 2025 or 2026, more of their instruments probably won't operate, despite their attempts. Though some may continue until the end of the 2020s, the mission's conclusion is drawing near. Our final communication from Voyager 1 is most likely going to arrive around the middle of the 1930s. NASA is making every effort to extend their mission and obtain as much valuable data as they can, as seen by these activities. Voyager 1's last voyage serves as a reminder of how people explore and acquire knowledge about space. The Deep Space Network, a system of radio antenna dishes placed strategically throughout the Earth's surface, will enable the transmission and receipt of signals. One of the largest antennas in the world, weighing 230 tons, is situated near Canberra, Australia. Even these powerful antennas have limitations despite their amazing size and power. In order to facilitate communication with spacecraft examining the depths of our solar system and beyond, the Deep Space Network is essential. These radio antennas are the vital connection that connects Earth to far-off spacecraft, enabling data, instructions, and information sharing between scientists and engineers across enormous cosmic distances. The enormous effort and accuracy needed for space communication is reflected in the enormous size of the 230-ton dish at Canberra, Australia. Its existence demonstrates humanity's commitment to delving into and comprehending the secrets of the cosmos. The Deep Space Network's antennas have limits despite their tremendous strength and advanced technological capabilities. Seamless communication is hampered by elements including air interference, signal deterioration at long distances, and the sheer size of space. Thus, even while the Deep Space Network is an incredible engineering achievement, it also emphasizes the continuous effort to push the limits of our knowledge and skills in space exploration. NASA's space scientists estimate that the two Voyager spacecraft will continue to communicate with the vast space network until around 2036. The amount of energy left in the spacecraft to transmit messages back to Earth will determine this. It is thus anticipated that at some point during this period we will have our final communication with Voyager 1, signaling the conclusion of a major space mission. We have learned a great deal about the outer regions of our solar system because to these Voyager expeditions, which began in the late 1970s. The farthest object we have ever created that is still traveling away from Earth is Voyager 1. We've learned a great deal about planets, their moons, and even the distance between stars thanks to it. Space exploration will no longer be possible with Voyager 1, but NASA has released new information on what's going on with Voyager 2, the spacecraft that was sent to be the second farthest object from Earth. Launched in 1977, Voyager 2's journey in danger of communication has played a crucial role in collecting vital information about worlds beyond of our solar system. Even with decades of operational success, this latest mishap shows how vulnerable these missions are. Voyager 2's contact with Earth may be affected by the antenna's movement, which might hinder the transfer of vital data acquired over the spacecraft's long trip. NASA engineers are definitely working hard to fix this issue and get the spaceship back in functioning order. However, this incident highlights how unexpected space exploration is and how vigilant one must always be to assure mission success. It serves as a reminder of the difficulties that come with traveling across the wide void of space, where even seemingly little abnormalities can have serious repercussions. An obstacle has been faced by the daring spacecraft Voyager 2 as it continues its voyage beyond space. As strong as the Deep Space Network's antennas are, they can no longer transmit vital information to Earth. This intrepid Voyager is currently 19.9 billion kilometers away from Earth, which is an incredible distance. But even in the face of these overwhelming obstacles, hope still lingers. NASA, the space organization in charge of Voyager 2's mission, is clinging to the hope that this communication barrier is really an isolated incident. Even with so much distance between Voyager 2 and its designers, the spacecraft's and NASA's committed crew's tenacity is evident. Even while the inability to communicate is clearly a setback, it is viewed as a manageable challenge rather than an impassable barrier. There is optimism that Voyager 2 will make contact with Earth again via creative problem-solving and persistence, enabling it to continue its mission of exploration and discovery in deep space. Voyager 2 resets itself many times a year in order to correct the alignment of its antenna with Earth. One important factor in perhaps re-establishing contact with the spaceship at the distance is these planned resets. The NASA crew is excited and hopeful about October 15th, which is when the next reset is planned. They are looking forward to maybe speaking with Voyager 2 again during this reset. This procedure emphasizes the need of careful preparation and perseverance in space exploration, since even mundane operations have the potential to yield important discoveries. The excitement is a reflection of scientists' strong bond with and commitment to the Voyager project, which has given them priceless knowledge about the outer regions of our solar system. Every reset represents humanity's continuous search to comprehend the cosmos and our role in it, acting as a ray of hope. Is it possible for Voyager 1 to survive until 2025? Share your thoughts in the comments section below and be sure to like and subscribe for more celestial videos.